Frontier Workshop. Frontier is a set of modules to build an Ethereum-compatible blockchain with Substrate. Getting started, you should have completed at least the following 3 Substrate tutorials before attempting this tutorial. Create your first Substrate chain, add a pallet to your runtime, build a decentralized application. Before attempting this tutorial, you should be familiar with the concepts listed below. Launching a Substrate chain, submitting extrinsics, adding, removing, and configuring pallets in a runtime Ethereum and EVM basics pallet design. Frontier template. This tutorial is presently a little bit out of date. While it is still a good reference, it refers to an older version of Substrate template. It is thus encouraged to generate your own template based off whatever commit you desire from Frontier itself to start working with many of the core features of Frontier installed and enabled. The Frontier project currently does not use the published Substrate crates. It refers to Substrate code from GitHub directly. Take note of this in your cargo files. You must use the matching version of dependencies for all of Substrate and Frontier in your project. This is a stopgap solution while Frontier is being updated to the latest Substrate tag release. There's also a GitHub repo template that is available for major Frontier releases pre-generated for you. Generation script. Generation script. You can generate a version of the Frontier template by running the generation script included in Frontier. The Substrate Developer Hub has generated the template using the included release guide, and intends to update with major releases of Frontier moving forward. You can use the pre-generated template or fork it from here, https://github.com/substrate-developer-hub/frontier-node-template/ Build and config setup. Genesis configuration. The development chain spec included with this project defines a Genesis block that has been pre-configured with an EVM account for Alice. When a development chain is started, Alice's EVM account will be funded with a large amount of Ether. The Polkadot UI can be used to see the details of Alice's EVM account. In order to view an EVM account, use the Developer tab of the Polkadot UI Settings app to define the EVM account type as below. It is also necessary to define the address and lookup source to send transaction and signature to be able to inspect blocks. Build and run. To build a chain, execute the following commands from the project root. To execute the chain, run. The node also supports to use manual seal to produce block manually through a PC. Query balance using a PC. Once your node is running, use the Polkadot.js apps RPC calls under the Developer tab to query get balance, address, number, with Alice's EVM account at 0xD43593C715 FDD31C61141 ABD0499 FD6822 C8558. The value that is returned should be Deploy and call Ethereum smart contracts. To deploy and call Ethereum smart contracts and test the related functionality, follow the next steps at Architecture. Here are a few helpful diagrams to help illustrate how the Frontier EVM and Ethereum RPC plug into your Substrate Frame runtime. EVM Palette Runtime Configuration. The Ethereum Virtual Machine, EVM, is a sandboxed virtual stack machine that is implemented in the EVM palette. The EVM is responsible for executing Ethereum contract bytecode of smart contracts, typically written in a high-level language like Solidity, then compiled to EVM bytecode. Ethereum Palette. The Ethereum Palette is responsible for storing Ethereum formatted blocks, transaction receipts, and transaction statuses. Wrapping Ethereum transactions. When a user submits a raw Ethereum transaction, we need to convert it into a substrate transaction. The conversion is simple. We just wrap the raw transaction in a call the palette Ethereum's transact extrinsic. This is done in the runtime. Ethereum-specific runtime APIs and RPCs. Our runtime is storing all the Ethereum formatted information that may be queried, thus we need a way for the RPC server to call into the runtime and retrieve that information. This is done through runtime APIs and RPCs. Further reading. Runtime APIs recipe about customer PCs RPCs in Frontier, FCRPC and FCRPC Core. Frontier block import. ERC20 contract deployment. The following steps are also available as a TypeScript script using Polkadot.js SDK. Contract creation. The Truffle directory contains a Truffle project that defines an ERC20 token. For convenience, this repository also contains the compiled bytecode of this token contract, which can be used to deploy it to the Substrate blockchain. Use the Polkadot UI Extrinsics app to deploy the contract from Alice's account. Submit the extrinsic as a signed transaction using EVM. Create with the following parameters. The values for gas limit and gas price were chosen for convenience and have little inherent or special meaning. Note that none for the nonce will increment the known nonce for the source account. Starting from 0x0, you may manually set this but will get an EVM invalid nonce error if not set correctly. Once the extrinsic is in a block, navigate to the Network Explorer tab in the UI, or open up the browser console to see that the EVM palette has fired a created event with an address field that provides the address of the newly created contract. EVM contract. Frontier allows you to run EVM contracts natively in Substrate. tightly integrated with the rest of the Substrate ecosystem. RPC compatibility. All existing Ethereum RPC methods work, so none of your dApps will break. Substrate module. Frontier can be easily integrated in your existing Substrate application as a runtime module. Frontier is the suite that provides an Ethereum compatibility layer for Substrate. It has two components that can be activated separately. Pallet EVM. This is the pallet that enables functionality of running EVM contracts. Existing EVM code can be used from there, using addresses and values mapped directly to Substrate. Pallet Ethereum with Ethereum-compatible APC methods. The pallet, combined with the APC module, enables Ethereum block emulation, validates Ethereum encoded transactions, and allows existing dApps to be deployed on a Substrate blockchain with minimal modifications. Frontier is not a bridge. Frontier enables you to run Ethereum dApps natively on Substrate, but does not deal with the issues of communicating with other Ethereum-based networks. If you want a standalone blockchain, you are looking for Frontier. If you want to create a parachain that has Ethereum functionality, you need to combine Frontier with Cumulus. If you do not want EVM functionality natively but want to communicate with other networks, you need the Parity Bridge project. Frontier is still under heavy development. We consider Pallet EVM to be relatively stable, while some parts of Pallet Ethereum's design might still be changed. In the future, using the wrapper block, opens new window, strategy, Frontier can also eventually function as an Ethereum client, allowing you to migrate any ETH1X-based blockchain seamlessly over to Substrate, allowing you to add Substrate specific features like on-chain governance and faultless upgrades.